Hello students, so today in this video we are going to understand the physical interpretation or physical meaning of the two very basic physical quantities, velocity and acceleration, and these two physical quantities you often encounter while studying the chapter motion. So let's start. First we will discuss velocity and then we will discuss acceleration. So suppose velocity of a moving object is given. We are going to take a random example. So suppose velocity of a given object is minus 10 I cap plus 4 j cap plus 6 k cap. So I hope and suppose the unit of the velocity here, that is SI units, it is meter per second. So obviously you understand that this velocity has been expressed in 3 dimension with 3 rectangular components. So let us make a 3-dimensional coordinate system. So suppose this is our 3-dimensional coordinate system, and this is our x-axis, this is our y-axis, and this is our g-axis, and we are taking right side of each positive direction of x-axis, upward is the positive direction of y-axis, and outward is the positive direction of g-axis. So what does this velocity we have written here that does mean? So basically here you know that this first term, the coefficient here written with I cap, that is the x component of velocity. Coefficient written with j cap is the y component of velocity, and coefficient written with k cap, that is the g component of velocity. So here you can write seeing this equation that x component of object's velocity is minus 10 meters per second, y component of the velocity of the object is plus 4 meter per second, and g component of velocity of the object is 6 meters per second. Now look at the different velocity components here. So Vx is minus 10 meter per second. So it is made up of two parts, minus 10 meter and it's 1 second. So Vx is minus 10 meter per second. It means that object is moving minus 10 meters in 1 second. Right? And why, what this minus sign indicate? This minus tells you that the object is moving in the negative x direction. So it is moving minus 10 meter in 1 second. So suppose this is the coordinate system and this is will be your negative x-axis. So object will move minus 10 meters in every 1 second. So after 1 second, where the object will, how much object will move in the x direction? It will move minus 10 meters. So suppose I say this distance is minus 10 meter. So in x direction object will move this distance. Okay. Similarly, if you look at the y component of velocity, it says 4 meter per second. That means object is going to move 4 meters in 1 second in y direction. It is positive. So object will move 4 meters in the y direction. So it will be somewhere here. Suppose I say this distance is 4 meter. So after 1 second the object would have moved this distance in the y direction. And similarly, if you look at the g component of the velocity, it is 6 meter per second, means the object will move 6 meters in 1 second, right? So in the g direction the object will move again in the positive direction, so it will move 6 meters. Suppose this distance from here to here, that is the 6 meters, object would have moved this distance in 1 second. So after 1 second the object would be somewhere here. So this point P, suppose I say this is x, y, g, its coordinate. Then if you will draw perpendicular from point P on x-axis, it will meet it here. If you will draw the perpendicular on y-axis, it will meet here, and perpendicular on g-axis, it will move here. Okay, it will meet the g-axis here. So you can write the coordinates. X will be minus 10 meter, y will be plus 4 meter, and g will be plus 6 meter after 1 second. And if the object is moving with constant velocity, then what will be after 2 seconds? After 2 seconds, similarly you will follow the unitary law. So in 1 second the object moves minus 10 meters. So in 2 seconds it will move minus 20 meters. The y, in the y direction it will move plus 8 meter, 2 into 4, and in g direction it will move 2 into 6, means 12 meter. So after 2 seconds the position of the object will be minus 20 plus 8 and plus 12 meter. So I hope you understand the meaning of velocity. One more thing I would like to discuss here. So suppose I make the coordinate system again here, and suppose the object's direction of motion I describe by this direction. Suppose the object was moving in this direction. So the point P was lying somewhere here. This was the point P. After 2 seconds, suppose this is the point Q, then point Q would also lie somewhere here. So object is basically moving in this direction. So if you find the magnitude of the given velocity, this velocity, then you can write magnitude of this velocity as the square root of x component square plus y component square plus g component square. So it will be minus 10 square plus 4 square plus 6 square. So it will be square root of 100 plus 4 square is 16 plus 6 square is 36. So it is 100 plus 16 plus 36, and how much it will be? It will be 116 plus 36 will be 42 plus 52, so square root of 152. So how much this will be? Square root of 152, let us calculate it. So 152, and its square root is 12.32, or you can write 12.3 simply, meter per second. So this is the magnitude of velocity. So means if you know the direction of the motion, then you can say that effectively the particle will move 12.3 meters every 1 second. So on this line the object will be moving 12.3 meters every 1 second. So this distance from point O is the origin, the distance of point P from origin, that will be 12.3 meter after 1 second. After 2 seconds, again it will be multiplied by 2. So distance of point Q from origin O will be 12.3 multiplied by 2. So it will be 2 3 are 6, 12 2 are 24, 24.6 meters. Similarly, suppose after 3 seconds the particle will be somewhere here. Suppose this is the point R, then distance of point R from the origin O will be 3 times the distance traveled in 1 second. So it will be 3 3 are 9, 12 3 are 36.9 meter. So I hope you understand the meaning of velocity. Now let's come to the acceleration. So if you know, the acceleration is also a vector quantity like velocity, and unit of acceleration is usually meter per second square if you write it in SI units. So basically the definition, if you know, the acceleration A is defined as delta V divided by delta T, means rate of change of velocity with respect to time. So best example of acceleration we can consider, that is the acceleration due to gravity of Earth. And if you know, the acceleration due to gravity of Earth is minus 9.81 meters per second square. So here minus sign is used because suppose this is our Earth and you take the vertical upward direction as the positive direction, so vertically downward direction will be negative direction. So the acceleration due to gravity is always vertically downward acting, so its direction is taken minus. If you are taking upward direction positive, if you take downward direction positive, then you will write it with plus sign. So that's not a big issue. Main thing is the acceleration magnitude is 9.81 meter per second square. So acceleration always acts downward and the magnitude is 9.81 meter per second square, and acceleration direction is always towards the center of the Earth. And let's elaborate this 9.81 meter per second square little more. So it is 9.81 meter per second square, and you can write it as 9.81 meter per second and per second, right? So you can write 9.81 meter per second square as 9.81 meter per second per second. And what does this mean? 9.81 meter per second, this is the change in velocity. Okay, 9.81 meter per second, this is the change in velocity which is taking place every second. So what does this mean? Suppose you have an object and it is dropped from a certain height above the Earth. So its initial velocity, suppose I say its initial velocity Vi is 0. So what will be its velocity after 1 second? So velocity change, we know that is going to be 9.81 meter per second every second. So after 1 second, and this direction is downward. So after 1 second, the change in velocity of the object, that will be downward, and how much it will be? 9.81 meter per second. So after 1 second, t is equal to 1 second. Suppose it was dropped at t equal to 0 second. So after 1 second, the velocity of the object, that will be minus 9.81 meter per second. Minus sign just because you have taken the downward direction negative, and change is 9.81 meter per second. So if initial velocity was 0, so after changing it by 9.81, it will become 9.81 meter per second. Similarly, after next 1 second, means at t equal to 2 second, how much velocity change will be? Again, after 1 second, velocity change will be 9.81 meter per second, but it already has a velocity of 9.81, and if you further change it by 9.81, it will be added because the acceleration is acting in the same direction as the velocity. So after 2 seconds, the velocity will be multiplied by 2 because 9.81 it is already having, and further you will make a change of 9.81, then velocity will become 19.6 meter per second. And similarly, if you write at 3 seconds, then its velocity will further be changed by 9.81, so 19.6 plus you will further add 9.81, so it will become 3 8 are 24, 3 9 are 27, so it will be 27.4 meter per second, and because you are taking downward direction negative, so it will be minus 27.4 meter per second. So I think you understood the meaning of physical meaning of acceleration. So 9.81 meter per second. This means acceleration gives you the magnitude of velocity change taking place per second or per unit time. So similarly, you can express it in vector form also. Suppose I say that acceleration of certain object, that is minus 2i plus 3j plus 4k cap, and suppose this is the unit is meter per second square. So you can further open it as minus 2i cap meter per second square plus 3j cap meter per second square plus 4k cap meter per second square. And what does this mean? Minus 2 meter per second square, you can write it minus 2 meter per second square in the I cap direction plus 3 meter per second square in the j cap direction plus 4 meter per second square in the k cap direction. And what does this mean? This means that the coefficient written with I cap, that is the x-axis direction, j cap is the y-axis direction, and k cap is the g-axis direction. So this means the first thing, this minus 2, that is the x component of acceleration, this is the y component of the acceleration, and this is the g component of the acceleration. So from here you can write ax is minus 2 meter per second square, ay is plus 3 meter per second square, and ag is 4 meter per second square. So it means that the velocity of the object in x direction, x component of acceleration means the velocity of the object in the x direction is changing by minus 2 meter per second every second. So again you can write it as minus 2 meter per second square can be written as minus 2 meter per second, means in the x direction the velocity of the object is changing by minus 2 meter per second every second. Similarly, in the y direction the velocity will be changing by 3 meter per second every second, and similarly in the g direction the velocity of the object would be changing by 4 meter per second every second, right? So suppose I say, let's take an example. Suppose initial velocity of the object, suppose I say that is I cap plus 2j cap minus 3k cap, this is meter per second. The question is, what will be the velocity of the object after 1 second? So because after 1 second the velocity in x direction, that will be changing by minus 2 meter per second. Initial velocity is I cap, means it is 1 I cap. So initial is 1, and after 1 second it will change by minus 2. So 1, and you will make the change of minus 2, it will become minus 2 plus 1, it will be minus I cap, minus 1, right? Minus I cap. And in y direction the velocity will change by 3 meter per second. It already has 2 meter per second, so after changing it by 3 meter per second, 2 plus 3, it will become 5 meter per second. And in the g direction initial velocity is minus 3, and it will change by 4 meter per second in 1 second. So initial is minus 3, and you will make a change of plus 4, then it will become 4 minus 3 plus 1, so it will be simply k cap meter per second. So this will be the final velocity of the object. So I hope you understood the physical meaning or physical interpretation of the two very basic physical quantities, velocity and acceleration, and I hope you enjoyed this video. So keep watching my videos and like them if you consider them likable, and share these videos with your friends also to support me. So thank you very much, take care, and bye bye.